Okay, thank you, Mr. Chairperson, for the chance. I would like to be glad to present my research on global research 2000. And I also appreciate all the university in the channel for organizing such interesting conferences on different thematic areas. In this presentation, I would like to talk to you about intensification of coffee, agroforestry system influences coffee leaf rust infection in south western Ethiopia. Here is the outline of my presentation, background, objective, material methods, analysis, and finally, at the end, I'm going to tell you major finding and conclusion. To begin with the general background, and very shortly, Ethiopia is located in East Africa, and where coffee Arabica is for the first time and discovered, and the home place of coffee. So geographically, Ethiopia is located in East Africa, and the home place of coffee Arabica, and only coffee Arabica is cultivated in Ethiopia, and Ethiopia is the sixth producing coffee Arabica in the world, and first in Africa. 50 to 60 million people involved in its cultivation, and coffee is the backbone of Ethiopian economy, and coffee contributes 5% of GDP, 25% of employment opportunity, and 30% foreign exchange currencies. And here in Ethiopia, coffee is currently cultivated in different coffee production system. Despite the different production system present in Ethiopia, current coffee yields across Ethiopian agroforestry system are lower than the actual potential, and 4 times lower than the coffee yield obtained in Brazil. And particularly, pathogens are the most serious one challenging the coffee sector. Importantly, coffee leaf rust, coffee berry disease, and coffee wilt disease. Of course, coffee berry disease and coffee wilt disease are locally important, but while coffee leaf rust is international important ones. So the coffee leaf rust significantly causes economic cost and estimated to be between 1 billion to 2 billion per year. So it's really causes huge economic cost in the world coffee industry. With this importance, currently it is not known how coffee leaf rust infection rate in southwestern Ethiopia differs between this production system. Therefore, the current research was initiated to quantify and compare the coffee leaf rust infection in southwestern Ethiopia in different coffee production systems: forest coffee, semi-plantation coffee, garden coffee, and plantation coffee, and also to assess temporal changes of coffee leaf rust infection in this production system. So with the method, the study was conducted in Gera, Goma, and Mana district of southwestern Ethiopia. And during the study, we used multi-stage sampling design where districts were selected successively, and sites were selected, stratified, using stratified disproportionate sampling design. We used 10 sites per coffee production system. In total, we surveyed 200 plus plot. During our survey, we assessed rest incidence, rest severity in different months during November 2029 and January 2020. So as to analysis, we used generalized linear mixed effect model using beta distribution with logic link function. Since our data is not normally distributed, we transformed the data in using this formula. During analysis, plotted forest fragment were included as random intercept, while coffee production system, the human impact indicator, altitude, and the interaction between management type and sampling type were included as fixed effect. So with the major finding, we found that coffee production system in southwestern Ethiopia significantly influenced coffee leaf rust infection rate, and as highest coffee leaf rust incidence and severity were recorded in the plantation coffee system, while the lowest coffee leaf rust infection measures were recorded in the forest coffee system. So the highest coffee leaf rust intensity in the plantation coffee system is likely related to the management intensity, while the lowest coffee leaf rust intensity in the forest coffee system can be well linked to the long-term coexistence of coffee and the coffee leaf rust. And we coupled with the high genetic diversity of coffee population and the high level of horizontal genetic resistance presence in the coffee system. And also we found that sampling time significantly influenced both coffee leaf rust infection. And generally, as coffee management intensity increased in the coffee production system in southwestern Ethiopia, is coffee leaf rust infection significantly increased. So the lowest coffee leaf rust infection in the forest coffee system at least suggests for future potential for screening of wild coffee arabica population, which is resistant to coffee leaf rust disease. So based on our finding, it highlights the conservation value of natural forest coffee system in Ethiopia. We also recommend not to expand coffee plantation into natural forest coffee system, as expansion of plantation coffee system further intensifies coffee leaf rust outbreak in the future. With this, I would like to thank KU Leuven, Belgium, and Gerba University, Ethiopia. And also I would like to appreciate my all advisors from KU Leuven and Gerba University. And thank you very much. If any question and suggestion, I would be glad to respond and react. Thank you so much.